So in the previous video, we introduced ourselves to a fundamental law, in working with surds, and we learned how it works, why it works, and we came up with a formula that looked like this. We had the root of AB is equals to the square root of A times the square root of B. This is what we wrote. This is what we discovered. And in this video, we're going to cover a couple of examples that basically deal, or in this case, show you how exactly this formula works. So let's say, for example, I had the square root of 3, and I told you I want to multiply the square root of 3 by the square root of 2. And I asked you to express this answer as a square root, right? That means you wouldn't have to go to your calculator to plug these values in and express them as decimals and then multiply them. You can just go ahead straightforward and multiply it like this formula shows you. Well, if we took root 3 as our root A and root 2 as our root B, well, that would mean we would have the square root of 3 times 2, because that's what AB is. It's the product of these two values inside the square root. So this would be square root of 3 times 2, which we can then simplify to the root of 6. Let's say I had the square root of 5 times the square root of 7. What would that be? Well, based on the formula again, it would simply be the product of these two values, the square root of the product of the 5 and the 7, right? It would be square root of 5 times 7, which should be the square root of 35. Let's try another example. Let's say we had the square root of let's say 3 times the square root of how about 5? Why not? Square root of 5. All right. What would this be? Well, this would be the square root of 3 times 5, which should be the square root of 15, right? So we can see this is a simple procedure, and there's nothing too complex about it. But this is under the assumption that we have the two separate square roots at first. What if that means, well, in this case, we've been working our way from this end going this way. What if we decide to go from here the other way? And let me show you what I mean. Well, let's say we had the square root of 20. And I say, I want you to express this value for me in two separate square roots. Well, let's think about this for a second. Let's think about the factors of the root of 20, because what we're going to be doing is just breaking it down. The way we have root AB broken down to root A times root B, we'll be doing the same thing with root of 20. But let's think about two factors of 20. How about 10 and 2, right? How about 10 and 2? Well, what would that be? That would be the square root. Right? Instead of 20, we can just rewrite it as 10 times 2, right? But notice here, in this case, the square root of 3 times 2 was the same as the square root of 3 times the square root of 2, right? And it works again with our formula. So doesn't this mean that we can break this up even further and say this is the square root of 10 times the square root of 2? That's what it absolutely means. It absolutely means this. But remember this: the square root of 10 and 2 are not the only factors of 20. We can do the same thing with 5 and 4. And you notice something here, something interesting happens here. Well, we can express 20, right, as 5 times 4. So this would be the square root of 5 times 4. And if you look again here, we can break this even further up into the square root of 5 separately times the square root of 4. And it makes sense, because if I told you, if I hadn't given you this value here first, if I hadn't given you this in the beginning, and I only gave you the root 5 times the root 4, what would you do? You'd tell me this is the square root of 5 times 4. So the reverse should just mean separating them, right? That should make sense. So the square root of 5 times the square root of 4. And I want you to know something here about surds. Usually when we're working with these surds and square roots, we take square roots to be positive. We try to ignore the negative value of the square root. So in this case, we have a special square root over here, the root of 4. The root of 4 has a whole number as a square root because the square root of 4 is 2. So this would then mean this would mean that this is the root of 5 times 2, which we express as the 2 root 5. And we tend to prefer expressing surds, these big surds like this, because we want a smaller number in the square root and we want to crunch it up into one value rather than having it expressed as the square root of 10 times the square root of 2. You would not be wrong for saying that the root of 20 is the square root of 10 times the square root of 2, but when it comes to calculations, you'd really prefer to have it all sort of crunched up and squeezed into this small single value. So let's try this one more. Let's try with another value. Let's say we had the square root of 8. Square root of 8. Well, let's think about the factors of 8. And if you I hope you don't think about 8 times 1. If you think about 8 times 1, well, what are you doing? This would be the square root of 8 times 1, right? Well, this would be the same thing as the square root of 8 times the square root of 1. Well, the square root of 1 is just 1, so you've not really changed your value. You just have been saying this is the square root of 8 times 1 as a whole, which is still square root of 8. You've not re-expressed this surd in a much simpler fashion. You've just said the same thing. That's why we tend to ignore the factors of 1 and the number itself. So any other factors you can think of that give you 8? Well, that would be 4 and 2, right? So you'd have the square root of 4 times 2. What would this be? This would be the square root of, well, this would be the square root of 4 times the square root of 2. But as we saw here, the square root of 4 is positive 2 because we ignore the negative values. And what would that mean? That would be this would be the 2 times, this would be 2 times the square root of 2. And again, I showed you we can express this as 2 root 2. And that should make sense to you, I hope. So we're going to be working out with surds like this. Let's try one more. Let's say I gave you the root of 90. The root of 90. Now you see 90 here is a big number, huge number. So it probably has tons of factors. But you tend to want to pick out the factor that has a whole number as a square root. In this case, we picked out root 4. So if I think about the squares, the factors of 90, 10 to 9, well, 10 to 9 come to mind. 3 and 30 come to mind. 3 and 30 come to mind. 6 and 15 come to mind. Is that right? No, sorry. 4 and 15 come to. Whoops. Well, I'm not doing my math right here. Yeah, 6 and 15 come to mind. My bad. And other factors. But I notice here that in this factor, I have a number which has a whole number as a square root, and that's 9. Right? Because the square root of 9 is positive 3 or negative 3, but it's a whole number. So I can rewrite the root of 90 as the root of 10 times 9, which I can then break down further to the square root of 10 times the square root of 9, which I know square root of 9 is 3, so this would just be root 10 times 3, which is 3 root 10. And that's basically it with surds. That's basically how we multiply surds and how we can express them in interesting ways. These are the basics, and the further videos we make or we can go through, the more complex we try to make the equations. But I hope you get the hang of this. And as always, go online or wherever you can, some textbook or whatever you can, grab a couple of questions, work them out, check yourself, and if you have any problems, please comment below. Okay. So I'll see you next time. Thank you.